Back, guys, to the second part of the lecture entitled Antacids. Before carrying on with the second part of the lecture, I want to apologize for the pronunciation mistakes and also the grammatical mistakes that I committed during the first part. It's quite, I would say, challenging to record your voice over presentation because you will discover first this is because you will discover that you commit many grammatical and pronunciation mistake while you are speaking in a foreigner language, especially with English, because English is my third language. I studied in France in French, and also here in Lebanon in France in French, and that made moving to do my PhD in English easy at the writing and thinking level, but when it's come to pronunciation, it's a bit difficult. I want to remind you of the summary of the first part of the lecture, that is, antacids are able to relieve symptoms of excess of acid in the stomach. The higher the acid, so when we want to compare effectiveness of antacids, the antacid with the higher acid neutralizing capacity is the antacid that is the more or the most effective. Antacids are weak base, and this weak base, when they are in a solution in the presence of a strong acid, they will neutralize it and they will transform it to a weak acid. And as a end and as a at the end of the reaction, we will obtain a weak acid, and the antacid, and this will make a buffer, will constitute the buffer that will maintain the pH. Yes? So let's go now to the following step, that is the outline of the talk of today. Of this part of the lecture, the title of this part is called Measurement of Acid Neutralizing Capacity. We are a quantitative lab, so we need to quantify and therefore to measure the value of acid neutralizing capacity. The first part of the lecture will be about if it's possible to measure the acid neutralizing capacity using a direct titration. We will try to do it. We will see if it's possible or no. The second part of this lecture will be about what are the limitations of using direct titration in order to measure the acid neutralizing capacity. And if there are limitations, what are the solutions for this limitation? The third part of the lecture will be about introducing the indirect or back titration as a way to measure the acid neutralizing capacity. This will take us to the experimental part, and here I want to advise you to watch the YouTube video. I sent you a link. Please watch the video link or the link video, and this will help you to understand better the experiment. So here at the part number 4, you have to watch the experiment and then follow with number 4, and then go for the calculation part, which is what you are responsible for mostly for the exams, but also for the experimental part. There will be questions about the experimental part. So how can we measure the acid neutralizing capacity of an antacid? Can we use a direct titration? This question, we will try to answer this question during the current and the coming slide. We all know that an antacid, it's a it has a basic chemical nature. So how can we quantify a base? Simply by titrating this base against an acid of a known concentration. Yes, this is one of the basic knowledge in acid-base chemistry lab. So this is a picture of an titration setup. In the burette we will put an acid of known concentration. This will be our titrant, and in the Erlenmeyer we will dissolve the antacid. The antacid will be our analyte. We will dissolve it in a known volume of water. Yes, we all agree on that. Of course, we will add an indicator. We will carry on this titration. We will open the burette cock, and then when we start to see a change in color, we close the burette stopcock, and then we write down the volume or the burette reading. Depend from where we started. If we started from 0, then we will write down that we arrive at till 15 milliliter, and then the V equivalence is 15 milliliter. Then we write the equation that say that at equivalence the concentration, the number of mole of the acid is equal to the number of mole of the antacid, and therefore the concentration of the antacid is equal to the concentration of the acid multiplied by the V of the equivalence of the acid divided by the volume of the antacid. This will generate the value of the concentration of the antacid in mole per liter, and from the concentration of the antacid in mole per liter we can get the acid neutralizing capacity value in millimole per gram, from mole per liter to millimole per gram. We will speak about that later, how to go from mole per liter to millimole per gram. But just I want to tell you something, that this method doesn't work at all. And the answer or the reason why this method doesn't work at all is in the coming slide. But just to tell you that direct titration for antacids doesn't work. So what are these limitations when using a direct titration of an antacid? First, there is a limitation that concerns the titration itself, whatever the titration is, direct or not direct. We need to know that the reaction between the antacid and the acid is reversible, and this doesn't work when we make a titration. In order to succeed in a titration, we have to have 3 conditions. First, the reaction is complete, so it's irreversible. The reaction is fast, and the reaction happens in a stoichiometric ratio. The compound react with each other in a stoichiometric ratio. However, here we see that the reaction between the antacid and the acid is reversible, and therefore the titration, whatever is direct or indirect, will not work. This is the first limitation when we go to titrate an antacid. The second limitation is about the titration itself. The analyte, which is the antacid, is not soluble in water. So when we put the analyte in water in the Erlenmeyer in order to titrate it, is not soluble, and therefore the direct titration cannot be used. So we have 2 limitations here in this process. What are the solutions for this limitation? Let's first start to find a solution for the first idea, that is that the reaction is reversible. The reaction is reversible, so we want to work to find a solution in order to make this reaction irreversible. How? By heating up. So the reaction will be heated during the procedure to favorize the formation of carbon dioxide gas. And by favorizing the formation of the gas that will become evaporated, the equilibrium will shift into the right to make more of the gas, because there will be non-equilibrium. So in order, the equilibrium will start to fix the solution by making more gas, and by making more gas and gas will start to evaporate, all of the equilibrium will shift to the right and will make the reaction irreversible. You got the idea? So CO2 in the aqueous will start to make more CO2 in the gas form, and this will shift the equilibrium. The carbonic acid will make more of the carbon dioxide, and the bicarbonate will make more of the carbonic acid, and so on. So now we fixed the problem of reversibility of the reaction. There is another problem, that the analyte is not soluble in water, and therefore direct titration we cannot apply it. The solution for that is called back titration or indirect titration. Indirect titration is made of two steps. First, the antacid that is not soluble in water, we will dissolve it in a known excess amount of acid. An acid, of course, is able to dissolve the antacid, but we will add acid, known amount of acid, into the antacid, and this known amount of acid is in excess, so is able to neutralize the antacid, and there will be still leftover acid, remained acid, excess acid after neutralizing the antacid. So first we add known excess amount of acid. They will neutralize the antacid, and there will still be leftover acid. The second step of back titration, we will titrate the leftover acid by a known amount of base. Don't know if you got the point. For people who didn't get the point, please follow me during the coming slide. This slide is made to convince the people who didn't get fully the idea of back titration. So always when we speak about titration, we speak about number of moles. Yes, I already mentioned that during one of my lectures. So in back titration, we want to add first a known excess amount of acid to dissolve the antacid that is not soluble in water. This known excess amount of acid, we will call it always N initial, number of mole initial. It is the number of mole of acid initially added to the tablet of antacid in the Erlenmeyer. Nice. This number of mole initial of acid is equal to the number of mole of acid that reacted with the antacid, yes, plus the number of mole of acid that are or is left over, remained intact. They didn't enter in reaction with the antacid. Yes, there are moles of acid that left over because the acid we added is in excess. Agree? The third idea is that the number of mole of acid left over or remained acted, we will titrate them in a direct titration against a base. And the number of mole of acid that are left over are equal to the number of mole of base added from the burette. Why? Because HCl plus NaOH is equal to salt NaCl plus water. And therefore, at equivalence, the number of mole of acid is equal to the number of mole of base. This slide is only to motivate you to go to the link that I sent you and watch the YouTube video about how to conduct, how to do the experiment in the lab. Yes, so I rely on your cooperation. Now I rely that you have clicked on the link and you watched the video carefully. So the overview, and to give you value, since you are not able to go and to perform the experiment yourself, so here I am giving you the value that you need in order to calculate and to make the report. An antacid tablet of Reni as a mark. So we will work with a Reni tablet of weight. The weight of the full tablet is 1.208 gram. Is first crushed using a pestle in a mortar. So we crush the table and we make it as a powder, and then we take, because it's impossible to take the 1.208 gram from the mortar, that's why we will take the maximum amount. I was able to take 1.105 gram of the resulting powder, and I transfer it into an Erlenmeyer using a spatula. Then the next step was that I added a non-excess amount of acid solution, hydrochloride acid solution, 15 milliliter of concentration 1 molar. I transfer it to the Erlenmeyer using a pipette. Here we need to think about number of mole. Yes, the number of mole initial added into the tablet. Then a reaction will happen. The carbonate from the Reni tablet will react with the acid to give the carbonic acid, and the carbonic acid will dissociate into water and into carbon dioxide. But in order to make this reaction irreversible, this is a reversible reaction under equilibrium, in order to make it irreversible, the solution is then gently heated on a hot plate for 10 to 15 minutes, boil it for 1 to 2 minutes, and then cool it down in a water bath, because we need to titrate it. And of course, titration, we can't conduct a titration under heat. So we cool it down in order to titrate it thereafter. But by doing this, we transform the reversible reaction into a straight, complete reaction. Yes? And by doing this, we break the buffer. There is no anymore buffer. We have now the carbonate react with the acid to give the carbon dioxide and water. And if you are asking me Why we heat it up here? Because simply we need to quantify the carbonate, and in order to quantify the carbonate we need an irreversible reaction. Nice. We finished the first step of the back titration after adding the acid in excess, and we heat it up to make the reaction irreversible. The second step, we set up a back titration, and then we start to titrate the resulting solution that contain the remaining or the leftover or the excess hydrochloride acid, the remaining after they neutralized the antacid. There is no antacid, there is no carbonic acid, there is no bicarbonate. Those disappeared after heating up. The antacid was neutralized by the acid. There is only remaining leftover or excess acid, plus an indicator of course. And in the burette we put the titrant, that is a standardized NaOH of known concentration. We conduct the titration, we open the stopcock, and we start adding the base till the color, so the reaction that will take place is acid plus base, salt plus water. We start added the base till the color, a sharp violet color appear, and this is the end point, and here we stop the experiment. Let's go for calculation. Now we arrive to the last part, that is the calculation part, and we are dealing with the table that focus on the raw data. The active ingredient of a Reni tablet is made of calcium carbonate and magnesium carbonate. So again, calcium carbonate and magnesium carbonate. The mass of the active ingredient according to the manufacturer label is 680 milligram calcium carbonate plus 80 milligram magnesium carbonate. The weight of the full tablet is 1.208 gram. The weight of the sample we have used is a bit less, is 1.105 gram. The molarity of the HCl solution added into the antacid is 1 molar, and the volume of it is 15 ml. The molarity of the standardized NaOH we use it in the back titration is 0.1 molar. The initial burette reading of NaOH was 0, and the final burette reading is 15 ml. What are you going to do at home now to train yourself? This is your part. First you have to write the chemical equation for the reaction of acid with the active ingredient and the tablet of antacid. This, I will help you with this. So the carbonate will react with acid to give water and carbon dioxide. Of course, this reaction is irreversible in the presence of heat, so after heating. The second things that you need to calculate it is the number of mole in millimole of acid solution initially added to the tablet. I think this is quite easy. Calculation of acid solution initially added to the tablet. There's nothing easier than that. The second thing is to calculate the number of mole in millimole of NaOH solution that neutralize the excess or the remaining or the leftover acid. I think this is quite also easy. to calculate the number of millimole of NaOH that we added from the burette into the Erlenmeyer. There is nothing easy than this. After this, we need to calculate the number of millimole of acid that was neutralized with the antacid. So again, now I need you to think a bit. We have the total number of mole added, the initially added. We have the number of mole of NaOH that neutralized the excess. Here we need to know what is the relation between the number of mole of NaOH and the number of mole of excess. The fourth question is the number of mole of HCl that was neutralized with the Reni antacid. Then, after finishing these easy steps, we need to calculate the millimole of active ingredient of Reni antacid. Again, we need to calculate the number of mole of active ingredient of Reni antacid. We will discuss this during the lecture. And the last one is the calculation of the actual value of acid neutralizing capacity. Again, you have to return back to know what is the definition of acid neutralizing capacity and how can we calculate it. And this was not the last part. The last part is to calculate the theoretical value of acid neutralizing capacity. This and other details will be discussed during our lecture in addition to your question. Thank you very much.